All right. So, just to conclude what we achieved so far, with this absorption, the gravity doesn't really play any active role. Okay? Because we know that it is a constant, it creates constant term, and that constant term can be added to the pressure. And this process of combining two pressures, well, I call it two pressures, two terms together, is essentially called or referred to as absorption of hydrostatic component, because what we have here is nothing else but hydrostatics, meaning that the pressure increases with depth. So you dive, the deeper you go, the higher the pressure. And this term is responsible for that. Okay? So what we can do, we can absorb this by formally including it into the definition of pressure. Okay? So therefore, in literature, you would refer to this term. If we do that, so essentially what I mean, this thing here is completely removed. And this term here is modified, so we give it a different notation, so P tilde, for example. So therefore, this term gets absorbed by the pressure gradient terms, and we refer to this pressure including hydrostatic component. Okay? So there are two types of pressure. One is hydrostatic. Static means it does not depend on time, it just depends on how deep you go. And dynamic pressure. The rest is what causes the force. Force is dyno in Greek. So dynamic means causing force. So this original term was causing the fluid to move or wind to blow. And now we combine that dynamic part of the pressure with hydrostatic part of the pressure and call it, say, full pressure, or pressure including hydrostatic component. The bottom line of that is the following. And the good thing I have this board where I can easily erase things. This equation becomes, okay, and is it possible just to create a copy of this and save it, because I'm going to modify that and I would like to have two. If not, then I will have to rewrite this. Just copy this page and save.
You can save this page and then you can again save it later.
Okay.
I just put it time.
Yeah.
This is it.
Okay.
Yeah. And then.
Yeah. All right. So anyway, so we have the previous version. And now what I will do, I will erase everything which will not be needed for our future computation. So first thing to be erased is this term, because we will absorb it there. Okay. So therefore, I will get rid of, we don't need any of that. So we don't need any of that, we don't need any of that, we don't need any of that, don't need that, that. None of that. And whenever algebra becomes simpler, our life becomes simpler. So that's why I have no regrets doing that. So we did it once, we know where what is happening, and now we simplify our life. So this is gone. Now, look at what we have here. We have all these quantities marked by stars, meaning that they are non-dimensional quantities. From now on, it would be just too cumbersome to try to draw these stars all the way. So, but from now on, we will only be working with non-dimensional equations. We will never ever try to solve dimensional physical equations, because that is a waste of time. And that's what you need to remember for in your own research. If you are dealing with physical problem, and if you need to solve it, before you do, non-dimensionalize that. Go through the procedure, determine the type of parameters, and then, only then, after you non-dimensionalize that, try to solve that. Analytically or numerically, it does not matter, but that's very important for you to remember that. Unfortunately, I'm fighting my engineering students in Australia, and they just do not understand that. Okay, so hopefully you are better than them. Always non-dimensionalize the problem before you try to do anything with it. So, having said that, I will take the liberty of removing the stars as well. So I'll just identify non-dimensional equations with their dimensional counterparts, and I will understand whether the equations are dimensional or non-dimensional by context. Namely, if the equations are dimensional, then I will see density appearing explicitly. If density term does not appear explicitly, that means the equation is non-dimensionalized. Okay? So that is the common convention, or in scientific papers, frequently you see that this non-dimensionalization is performed, and then the authors say, well, from this point on, we drop all these stars. But we still deal with non-dimensional equations. So here it is. Look how much we achieved. We started with a system involving 6 physical parameters. We got rid of all of them. All of them are gone. So there is not a single parameter left. And we didn't lose anything. The solution of this equation, non-dimensional solution, once obtained, it can be trivially rescaled back to the physical quantity. All you need to do is to, well, take, for example, you compute the velocity u, non-dimensional. You take it and you multiply it by that, remember, v. And that's it. It's the final answer from your analysis multiplied by a constant, and you will get what you want. And this analytical solution needs to be obtained only once for all problems you can imagine. Okay? Not only that, but we also got rid of one of the terms, hydrostatic terms, and this is also a common practice. As long as gravity remains constant, as long as density remains constant, then gravity can be absorbed into pressure. And that's what we will do throughout this short subject. So we will try to keep algebra to the minimum, and therefore we will include a lot of simplifications. We will consider incompressible fluids, which means with constant density. We will consider constant density. We will not consider a salinity change or something like that. So we will consider constant density, truly constant density. Okay? So we will see, we will consider initially inviscid fluid, but later on we will relax this assumption and we will consider fully viscous fluid. And that will be plenty for us to cover in this short subject. Here we go. So, by looking at this equation, I would ask you, without going through the procedure of non-dimensionalization, just add the rest of the terms or rest of the equations to the system, right? And the rest, by rest, I mean, so since we decided to consider two-dimensional case, so this is U equation, so write down similar equation for V component, right? So add to that to this system. So obviously, if the flow is two-dimensional, so this is not going to be there. Agree? So if we are truly considering two-dimensional case, so we can get rid of that. So let's do that. So this is gone. So I will get rid of this as well. So this is what you have. Try to see the pattern and write down the second equation for velocity component v. And also remember we have that incompressibility condition. Divergence of v of a vector v is equal to 0. Write it explicitly there. So show me what you get, or tell me what you get for two momentum equations. So these equations, by the way, they are called momentum equations because they consider the how fluid momentum is affected by external forces, right? So and equation, non-dimensional equation for the well, incompressibility condition. Okay, I ask you to do that without formal derivation, but by recognizing the pattern. Okay, if you recognize the pattern, then it will be a good skill for you to have, because recognizing the pattern saves you from many errors, making errors. If you see that the pattern is not quite right, something is wrong with the algebra. Okay, so tell me what the equation is going to be like for velocity component v and for incompressibility condition.
Right.
So you want us the next step to very well.
So clearly, if it is so again, then we're just going to sit for that. So what are we the second thing?
So you were not able to
Okay, so that was the first thing. So this is one of the G, this is all of the L. The next one would be double. And so this and this
Come together. This and this come together. This and this come together. So the next one will be dv by d.
it's
correct?
Plus
infinity.
And this is going to be culture.
And that's our data scheme. And then my data was
Right. So quick.
So yes, this is just a straightforward recognizing the edge.
and last equation is what is referred to as continuity equation, which we recognize that it is not continuity but incompressibility equation. How will it look? Okay, so here we go. That is the generic system of equations that we are will try to solve in particular, subject to particular boundary conditions. And one thing I always ask my students, and for you it is of course probably not a surprise, because you are much more advanced students. I ask them a question. Look, this is a system of equations. And it is generic system of equations. But we know that in reality, the variety of fluid flows is huge, and one flow does not look like the other at all. But it is the same system of equations. We just derived it, right? So there is nothing else. So how can it be? Single system of equations, but infinitely many solutions. Where do they come from? Why? How do they exist? What actually makes the solution to look different if equations are the same? What do you think causes this difficulty or difference? Boundary conditions. Exactly. So because here we do not specify any boundary conditions. And if you change boundary conditions and they come into play through, for example, geometry, right? So how do we define geometry of the flow? Well, if it river flows, if it is a straight canal, well, you will see one type of flow. If it is a river which winds around, completely different flow. So the shape of the boundaries, that's essentially algebraically, that's boundary conditions. So boundary conditions, change boundary conditions, you change the solution completely. Okay, so it's not equations, it's boundary conditions what make things different. Okay, Good. Now, let us look at the structure of what we have here. Just before defining the rigorous meaning of the term, I will just appeal to your intuition. And I will ask you, are those equations linear or non-linear? Non-linear. Okay, correct answer, even though I didn't say what non-linearity is. Next thing, what makes them non-linear? So, is this term linear or non-linear? This one? This one? This one? Great. So we understand what is linear, what is non-linear, right? So I don't really, well, you know that either no rigorous definition or just by intuition. Fine by me. I will not spend my time in explaining. So these are non-linear terms, these are linear terms. So equations contain both linear and non-linear. Let us say that somehow we were able to solve this system of equations and get some sort of simple solution. The question is, could there be other solutions? So based on what you said, let's somehow, by God's intervention or by somehow, by epiphany, well, if you know what Christian terms are. So you guessed or worked out one of the solutions, some function which satisfies these equations. Is there a possibility for another solution? Well, trivial solutions, well, if you have trivial solutions, so that means that you have trivial boundary conditions, in a sense. So if you have non-trivial boundary conditions, right, or if you have any sort of force, you cannot have trivial solution because a system must respond to forcing, which comes either through the boundary or through the bulk. So for example, if pressure gradient is applied, you cannot have a trivial solution. Now, what I'm saying about not the type of the solution, not just the fact, if you have one solution, can there be another solution? In principle. And give you a hint that this is based on what I asked you before. And what we discussed before, linear, non-linear. So, we determined that this system of equations contains nonlinear terms, and therefore, overall, this is a nonlinear system of equations. The question is, can we have essentially multiple solutions? And the answer generally is the correct answer is no. The correct answer is I don't know. And this is honest and completely correct answer, because whether you have or don't have extra solutions, additional solution, will depend on many factors, including boundary conditions and initial conditions and you name it. So anything is possible with nonlinear systems. Okay? So if the system is nonlinear, you cannot exclude the existence of multiple solutions. You simply cannot exclude that. If the system is linear, you can say for sure you found one solution and it satisfies the equation, satisfies boundary condition. Look no more. There will be none. Theorem of uniqueness, essentially. There is no theorem of uniqueness with Navier-Stokes equations and with any nonlinear equations. And uniqueness of solutions of solutions in the three-dimensional Navier-Stokes equations. This is so-called millennium problem. You solve it, you get $1 million, right? Go ahead, be my guest. I'm passing on that. So, anyway, and that's what the stability theory is about. It's trying to determine whether we can potentially have a second solution or third solution or whatever solution, multiple solutions. And if so, can we at least approximate them? I'm not ambitious enough to say, well, we will be able to find that exact form of that solution. No, at least give me a hint that it exists and maybe some hint about what it looks like. So that's as much as I want. So if we happen to find the solution of this system somehow, clearly it was a simple solution. You cannot expect find a complicated solution and miss the simple solution. It just doesn't work that way. If you found it, it is a simple solution. And because of that, the terminology is that simple solution that you might be able to find is called basic solution or base flow. Okay? And linear stability theory or stability theory in general deals with determining whether this base flow that you happen to find, simple one, is actually realistic. Can you actually see that flow in reality? And the general answer is, if it is stable, you have a chance. If it is unstable, you have no chance to observe it. Something else will be seen. Okay? So that is our goal. Somehow try to extract the information about the possible multiple solutions out of here, assuming that we were lucky to guess or work out one of the simplest solutions. And what I mean by simple solution, usually it is a solution which is obtained from these equations by making all sorts of simplifying assumptions. What do I mean by that? For example, this is equation which contains variation in x, y, and t. The first thing is, well, is it possible to find a steady solution? Steady solution, which means that these terms are gone, d by dt. Next thing, is it possible to find the solution which corresponds to the so-called parallel flow? So what is parallel? When you have only these functions u, v, that depend on, say, only on the variable y, but not on x. Right? If you have a channel, so something changes across the channel but not along the channel. Right? So these sort of assumptions are made to find a possible simple solution which we will call base solution. And then the question, of course, is, well, what we obtain here, so we are lucky to obtain it, we are happy to obtain it algebraically, but is it really realistic? Can we actually see that? And if we can see it, can we do something about figuring out what we actually can see? So that's what our goal is. So how do we proceed with that? And that's where I will ask your help again, and once you finished with this task, I probably will call it a day. So let's assume that you have the solution that is of the form the bars correspond to lucky guess, base flow. So this is base flow. These are called perturbations. And I will refer to the very first hour of our lectures today. Remember when I considered the amplitude equation, Landau equation, right? So I introduced a bar and small a. And I call a perturbation. So here I will introduce primes because we already have u and v and uppercase, lowercase, so we need extra notation. So primes will denote so-called perturbations. These are small quantities in that sense that if we assume that u prime exists and non-zero, then it is much smaller than u bar. Okay? So what I would like you to do is to take these, substitute them here, keeping in mind that U bar already satisfies these equations on their own. U bar, V bar, and P bar, they will satisfy the equation, right? And therefore, they are completely balanced, so therefore you will be able to get rid of them. And you will see that the rest of the equations will contain these prime quantities, the remaining terms. And they will be either entering linearly or non-linearly. And I would like you to show explicitly how they enter into linear terms and how they enter in non-linear terms. Collect all linear terms on the left-hand side, on all non-linear terms on the right-hand side. And once you get this, once we discuss the structure of those equations, that will be the end of today's classes. Okay? So take these, substitute them there. So break the brackets. So in all these non-linear terms, keep the linear terms on the left, non-linear terms on the right. We discussed them. And after that, we will stop and we will continue from this point onwards tomorrow.
Excuse me, sir. Yes, sir. May I please know whether the base quantities are function of y only? One fixed.
These ones,
Yes, yes.
they could be anything. Right? So in general, they could be anything, we just assume that we load. And they are of reasonable size, while these ones are small. Okay? And all I want you to do is to split the equations so that the linear terms are on the left, non-linear terms are on the right, so that we can discuss the structure. And by the way, this procedure here is completely generic, so we apply it for to Euler's equations, which are describing fluid flows. But if you have equations arising in any different area, physical area, for example, solid mechanics, the procedure, algebraic procedure, will be exactly the same. No difference whatsoever. Okay? So algebra will be exactly the same. It will be absolutely generic. So the only thing which you will change is this system, how the equations, original equations look like. But everything else is exactly the same.
Okay. I just see a little bit of a confusion there. Some people just combining this. So linear, non-linear. So linear and non-linear needs to be defined with respect to the variance. Because if we have basis for, we'll pretty be
So for example, function f of x, if it appears on its own in the equation, does not make it nonlinear. Function f of x multiplied by sine of x does not make equation nonlinear either, because sine of x is a known function. F of x multiplied by f of x squared, makes equation nonlinear. So in your case, what you showed me, you have product of u bar and u prime. But u prime is not known, but by our convention, u bar is already known. So therefore, this is qualified as a linear term. Okay? So u bar multiplied by u prime is a linear term. U bar multiplied by u bar is also linear term because we already know what it is. We don't need to solve it. Right? So from that point of view, it's only u prime multiplied by u prime. That's what is going to be nonlinear, because we don't know what it is. Okay? And what about nonlinear terms? No, don't neglect them. Just collect them in the right-hand side. So all linear terms in the left-hand side, nonlinear terms in the right-hand side. So we will need to look at them and before we actually neglect them.
Most equation simplifies can question like the near term.
These are linear terms because u bar is known. You have one unknown function which you multiplied by known function, it makes it linear. It's u prime times du prime would be nonlinear term. But this is linear, so that has to be on the left-hand side.
Near term divided into line, the left hand and right to the nonlinear, and then after to
So, all right, so first you need to substitute and then to decide what is linear, what is nonlinear, right? Because you will see from here, from these terms, you will get both linear and nonlinear terms, okay? So first substitute, take these equations as they are written, substitute everything in, so those substitutions should go in, and only after that decide what is linear, what is nonlinear. Okay. Anyone else?
I'll go out.
Oops. Slippery. Yeah. I should take my shoes off here because
It's quite slippery.
yeah. So yes, that's how you start. So all these are already balanced, so you get rid of that. Correct.
These two nonlinear.
So these are nonlinear terms. You push them to the right-hand side. Correct. And everything else must stay on the left-hand side. Yep. Yep. That's right. So just do exactly the same thing with the other two equations. So these are, this is nonlinear, right?
This one and
This one.
Yes, so the rest are linear terms. Yes, correct. So what I would like you to do is to keep linear terms on the left-hand side. And
grandson, young leader.
all right, so I will start writing the answer on the board so that you will be able to compare what you have with what the right answer is. And hopefully, if you did something differently, you will see why the answer is as I show. So I will create an extra page. So for linear terms in coming out of the first equation, I will have Compare it with what you have and tell me whether I'm right. Okay, so am I right? Thank you. So, some people told me that I'm right, so therefore those of you who didn't get this have errors. Trust your peers. All right, I will not take responsibility, I will not blaming you, so your peers blame you. So shifting the blame is one of the things you need to do with working with students, otherwise they complain and you have to respond. Anyway, does anyone have any questions about what I have here? So all the terms which contain only barred quantities are gone because they are balanced already. We solved these for them. So they left-hand side is equal to right-hand side, they cancel each other. Only the mixture terms remain, and in these mixture terms we have two types of terms. Mixture between the base flow and the perturbations, and mixture between perturbations. Okay? So clearly, the second equation will look, and again I will ask you to essentially follow the pattern rather than trying to rederive everything. So if you recognize the pattern, then chances are that you understood what is going on. Okay, am I right? So I'm not asking that because I'm sort of playing games with you. I'm just as tired as everyone else, but except I was standing here, so I might make stupid errors. So never trust me at the end of the day. Am I right? Okay, thank you. I take it as a compliment. So, and the last one is and that was simple. That's the simplest one. Because the incompressibility condition is actually linear. So therefore it produces the terms which look exactly the same as the original equation. All right, and that is the point I would like to make. Again, remember the pattern. So any terms that were originally linear will remain so. All you need to do is to, if you had u bar, you replace it with u prime in the time derivative. That's simple. The only thing which is not that trivial is nonlinear, how you represent nonlinear terms. And you can see that nonlinear terms produce more than one. So linear terms produce linear terms, 1 to 1. One linear term produces one perturbation linear term. But nonlinear terms, they produce many. In this case, only two. Why do you think they produce only two? Because nonlinearity is what sort of nonlinearity we have here. What order? How do we call this nonlinearity? Second order, quadratic, because it is one unknown function multiplying another. Like it's like a square, like u times v or u times u. So it is quadratic. All right, so therefore, the pattern is that linear terms will remain linear, and all you need to do is to replace bar quantities with prime quantities. That's the pattern. Nonlinear terms you have to be careful about because they produce multiple terms, right? So you need to make sure that you deal with them correctly. And nonlinear terms is whatever is left. So, where to from here? So I'll just discuss with you plan for tomorrow. And after that, we will stop. So for tomorrow, the plan is we will introduce some sort of more or less realistic geometry. We will discuss what bar quantities are using our gut feeling, intuition, experience, whatever, but probably not necessarily algebraic skills. Once this is done, we will obviously substitute these bar quantities in these equations. And once this is done, we will make a step that I showed from the very beginning in the example of Landau equation. We will neglect these nonlinear terms for the time being, because if u is small, u prime is small, u primes times u prime is even smaller, and we can neglect that. This way we will obtain a system of so-called linear stability equations, linearized equations, because all the remaining terms are necessarily linear. And then we will discuss how we can solve it and what the solution procedure will involve, because this is still a system of partial differential equations, and it is not that straightforward to solve even linear system of equations. Once we do that, we will be equipped with a major algebraic sort of toolbox that is absolutely generic, has nothing to do with physics of fluids. As long as you are given a set of equations, no matter where they come from, you will be able to do the same toolbox. Okay? So hydrodynamic stability or solid state stability or you name it stability, all will be exactly the same. They will result in the same type of equations, completely generic. So we will discuss what to do when these are not there. It will take us some time, so there are quite a few things to learn about that. After that, we will try to do the same thing, but now by including more realistic effects. Viscosity. We know that fluids are viscous fluids. They get stuck to the wall. They do not slide along the wall. Once this is done, again, I will introduce some sort of physically relevant example, namely Poiseuille flow. So we started talking about the flow between two plates. I will continue doing that because it is a simple flow, algebraically simple. A lot of things can be done by hand, so to understand what's going on. And after that, in the last day or so, maybe last 2 days, we will be focusing on that. What do we do with these terms? Okay, nonlinear terms. And that's where it becomes really non-trivial. Okay, so that's basically, so today's start was quite intense, but it was sort of repetition or a review of what many of you already knew. So tomorrow we will start adding some specific stuff, linear stability stuff. And in the last day, it will be pretty much state of the arts. So that is what I was doing for pretty much for my career and what to do with these terms. So this is, well, that's more or less the latest in the field. Okay, that's the program in a nutshell. So I will post my lecture notes, relevant lecture notes, in the Google group. So I just need to work out how to access it. So if it is not going to happen, if it is not tonight, then definitely will be tomorrow. So you will see the lecture notes, my handwritten notes, not necessarily these ones, but the ones which I refer myself, and they have a lot more details. And in addition to that, you will have a typeset study guide. So study guide, what I call study guide, it's not anything coherent. It is just a list of notes which I typeset answering the questions received from my previous undergraduate students. They are not necessarily necessary for you to get familiar with, because a lot of stuff there may be already quite well familiar to you because you are higher level students. But I will put it in for reference purposes, so therefore you will be able to refer to those. They are not comprehensive at all, so they are, I think, about 10, 15 pages in total there. But also what you will see there, a few questions like review questions, you can call them. Have a look at them, at those questions, and see if you can answer those questions. If you can't, so I do not require you to do it for sure. If you don't want to do that, well, fine by me. But if you try, and if something not quite clear how to answer those questions, I will be happy to discuss that with you. Okay? So that is the structure of material. So look for my scanned lecture notes. Look for that study guide. And whatever I ask you to do here in class yourself, so keep an eye on that, because at the end of this session, at the end of this course, I was asked to, well, don't blame me, it's not my idea, so I don't like that, but I was asked to offer you an exam, okay? So I've been a student once in my life, or maybe for more than you, so overall I was studying for 6 years for my master's, 5 years for my PhD, so at least 11 years of studies. Hated exams with all my heart, failed most of them, so I had to prove that I'm not fool even by failing them, but anyway, so that's my attitude towards exams, but rules are rules. So I will give you some sort of questions, and they will be similar to what I ask you to do here. So make sure that you understand what you are doing. So, and so far I don't think there are any problems. So expect me to ask you something what I asked already. Slightly different context. Okay, so I'm done for today. If you have any questions you would like to discuss with me now, feel free. If you would like to send me an email, so I gave it to you previously. So wait for things to be populated on the Google group whenever it becomes available. So you will probably get a notification that something appeared in the folder. So download it, keep the copy for yourself. And I see you tomorrow if you do not want to discuss anything now. Okay? Right, thank you.
Visto that is the and put that in the regards but like to this my certainly really don't you know look at school thing but distinction from that something to the people that's but you should make a shoot that so this they keep but is that he's actually I think it was is always that anyone out there but anyways we don't both day find this one we get some gas equation options. Like, no, that's mail that's silly. If you might have to yeah, so you can say, hey, this was a shame how things is so what is the room, some investigations, market, really. Is it eight? Also, they do it while lookings will have spit that would be why been making these different testimonies is as being your part is system look at the part, which is like you go because yes, that's a fucking stuff. And so Kev continues in the person, and she got you what this story that's when stuff's telling the things for I will keep things that I could see there. Those special make sure I can make you got then it is by frosty here in a man get this pray you see it keep on business to our game word seeing can publish to it in such a man what does almost like your scale which I'll eat to get those and so I couldn't even visit but what it needs what we are but why change the results well the family was in girls is a story because she did that. Yeah, you love anything about some the very true not getting some steady. You work is with us people still at food. I just did having this is yeah, the previous and it's actually kids. Try to think it out. Today's see of our sea because which kind of complex about the zones. There was some use, pieces like some base of the actors. Yeah. So that's all the things it will in see if I'm getting always a good by English. Today go about the circular these days stuff. Yeah, I can go into start use anything that's so that was but what push that in this little push somebody does this, and some teams, so I could delay our wish either I, but it was the days, but we were there, like it's a look at the death, we see that this is what does it take, this is this, but it's not, it's even when we make all these, yes, that's it, it's like, well, that in the end, that's the set, well, that's part. Unless that's the truth of the yeah, this is what the scale of this means. So, okay, still at the bar, bring it, yeah. I think the big cheese, suicide closet. He has which he leave like the effort, not like the but because she got with these suicide wanting that, yes, he said that's well, because how it's just within your problem. Yeah, that so what kind of you want to like see that the car but debts. Even it's saying that I'm still the thing and the sweet to other what acre. So that Melissa and a dash of it is a shank can eat the butchers. This coffee is the clothes is some saying should be some such they assume that's just somehow gets it out of history. Smells of heroes might and get it in wine the steaming and just if you like wow like you show these out there so you're getting up something and everybody realize sleeping or this and the piece does it outside it but these times you certain guilty. I say I see they not sure but the info is but the piece picking that but again was legit is I always so essentially if you calculate the mesh was cutting the wet as spacious like and secrets. Some idea also telling that was in dash day one some art is known as if what are the gracious out there in like the site like those agents. You have a chef party says we extend the other stuff that in one way such your sensitive. There's some tightly that I saw they have the shut. They living your stupid hard in desserts and being should be in a coach the same way you're going about it. Being so that's a piece of something so and then what it out there was very and grab this in fact. And so yes, and we will have the GDNs of like what two dance is the time to them young. That event so is eating the catching outside. You can toward X direction on the way to take them to a right motion where she achieved motivation and self loads. This is the panic of it. So, what in the CJ find them? Check should speak and real, run to the photos. He was the end. And that's something take. Sit front, he was like the office, doing a bit above it. And Marius like, then the screen ship of the bunches. He says, take a side to our hand, face, very stick. In this like trace, I'm not the side I go feet, with kind of months. So basically, that's the Lisa dance or the good last sick there. He's still happy yet to us. If there was the lose guy, the this house, he wasn't back to Japan. So, what I said, you should this tank will be it. Because the problem. And it's still straight work that kingdom, which the guy need to last go find it, stand the king's own station in Kirk was a quite the transition a response. So if what you piece of the power factor with this like this a so that case was still as you said, yes, okay, I need it doesn't need it, should that it there is the third is the up here to the town everything. They by shut. So if I was calling this was to do it, if they add so late be that shut and just let an inch per one of that. Double G, go to the easy thing out about the chocolate, because it is simply feet then the truly little thing, that's the gene, where was silent. To me, it calls still kind of so then this when you are it's very to a book doing you got what was shine or either cold pleasure cause it just was a culture stocks in so but this is discussed and bought those still of fusion to the breaking system right. What I see is the capital words, established in a serious culture that just accepts the right for a cheap bit. So, people like this is Apple. There is 8 sudden images that you are quite the sign. All nuts will only look what I am with you. So, the class on me. So, we are selling the heel. Scientists and also the sell. You someone for to what we can, yes, it is all smells in place. But causing the sun you got was showing the controlling. To get things with this like with sunny the heavens leading rain. All of that is things like the shout to evidence. Just clear that it be like the chance of these idols, but you look and they just feel like this is to go this way walking. This is awesome and sherry. So the decks and what you should sign with one something so and yeah, we would have a term from this of the deep way deals. Very nice. We would try to these to go out when it's simply what is this that you get amazed. Peace. But you should keep by near zebra takes but just workingness. Because it's called that then speakers they say it's looks yeah. You need like slides on it was you lost you look all time and I hope to. I mean, the things that are and scenarios, of course, see the little things that comes. So, big chunks that were can bring these boilers. And what they can say, yes, because this regional depression was silent fall for this one weekend. They did that piece. And that's like absolutely important for the other thing about this whole battle. Thinking about the names of colors, but I was and fiction. That's really benefits. Feeling I'm seeing this what is going serious engagement this could be the section the slow so that there's noise to get millions bodies and that is definitely a switch on no that is I think that doesn't have such a thing as well yet that's I listen to 5 cents of tens and nothing is this order should at least 0 something we used is your soul they two the people that that's sweet I didn't see one you like I've done this group. You say that's the zero utility. That's all issues. So what I'm doing as such things is that you can use players because so can fight for them. Your attention so just look at the one X if you wouldn't. So never really have that's the secret. Let's get on. I mean, was the floor seating technology shops they could go down. So then it's all that it's large of the good content such chapters and section. All the nuts days to you. And before this did that they probably scratching. Is the two things I did on the things outside. And that case, some other cases, the methods to become based on this, with something because we found amazing for 2 things about this hundreds of weddings have to let's go PC I can't say it's really for details, things they think and speaking the Messiah because the willing and he was the brick school machine that was what we see on the state detail instance and there was not all guns. Yes, and this stuff and this is known in the movie. This idea could get ever so strong that it's the sequence was that was so terrible. What was I that this reason the blame artist is on it. All the stuff will be mixed within like that. Rather to again, but so he decided there with the situation because it was a sort of what it's testing with what he's saying. All this because he could be more. It's so damaged. I'll do it okay, but being patient. For him, can stick right to one. But it ain't a fast one. Sure, just everybody is with one. The culture, to each of us, he fight with water. In this watching, we can nothing is survival trees. What's the technique by the CT? It is something this get up for a direct interview. Because I that was there is two of the action just in terms of Soviet orders. I think what the Soviet was that the is what like it's a and it is new war. Just what was the time the first city war. And we played this. Let's go lost. To get the military and so and they said he just like yes one step other things in the two things the people like this we were it's 10 I think it's that same was it the back secure in the and so that's what I mean that just on the trains into it's still the way down try to what to try it's just like my is down and see a lot of us what this is right it was that a sort of down on the place such down you explore but then there's a lot is that people I thought after she started the other slept up but she just you understand that is a plus like right now basically the 50 years and sisters to me I saw not only get to this commodity in the buy and now still these in the sound and don't want to buy them myself but it's still this I mean you're a lot of swag west and just still get that thing that's still you want to for something you have to do kind of you but beside the bed yeah and is a window to did you was how to do it would response like my divisions wait for still damnation as if that's sort of survival in this is quite but thing they I can't say we in fight so the news is never secret down money but operations all heck by out last situation and that's what I can find much that's kind of to figure out from this time that every good like things that say the is it on the wars of the Luton and the Sager. Just like this is something well this you'll say is material right so this is vocal this is estrogen your medicine weapons instead any kind of this is not type just this other issues for this going to be testing here disability is then the next because what have you seen here that baseball cares for patients that perturbation was something like a care based on the sort of essential that here we are going to sit in the camera what you were so sending to the rest well, so if I start checking the things, with that, right? So what we say, just the colors, why it over? So it's saying, but you pull them make them. So that's what that effectively. So therefore they affect each other. This thing that's what that happens. So one that's for the other is for so this so it is the idea really is that the flow carries some momentum. The best flow carries that the visual gratification into system but see not the place. Oh, they can't really
Just in one then he was so in one time
yes.
I'm asking them I don't go saying time. So in one time when the best study for that some bifurcation that. So why and for study bifurcation term in term for hydrodynamic stability means the means like Navier-Stokes equation. Momentum equation what look like that as well. Why we think we study bifurcation there.
Because remember what happened at bifurcation. So we had zero solution. You on the left, remember P4. So on the left, when sigma was 0 or less than 0, we only have a single solution. Like that, at the bifurcation, the single solution becomes a triple solution. And some of these triple solutions, so like 2 are in work, okay, the other one became unstable. So unstable means physically unobservable. You cannot see that, right? So in physical reality, you cannot see that. So therefore, the question of the question is, the system, original system is the linear. So can we have one solutions?
Yeah.
And the answer is yes. In that, what I demonstrated in the model. So in some regimes, non-linear systems, so the shape of the system does change. Well, in some regimes, it only has a single solution. That at some other regimes, you change the parameter, and all of a sudden, instead of a single solution, you have 3 solutions. And then the question is when it happens, and then the question is what can we actually see, right? So with the system of equation, with the model equation that I considered in the morning, it's everything clear. We see either 0, 9, 0, square root of the sigma over k, right? With Mendel's equations or with the Wilks model equation, it's not that clear. So yes, we will be able to say that something happens at a particular point and single solution becomes multiple solution. But the question is, what is the other solution that we will get? Okay, so that's the main reason. So we need to determine when it happens, where. So as we change the parameter, something happens and single solution becomes multiple solution. And that the next question is, if it is multiple solution, which one of these multiple solutions can we actually see in physical reality? Okay, like so, because some of them will be observable, some of them will not be observable. That's the practical question. Things are different. We will see the chain of flow either is just flow, letting us flow, which goes through the pipe. So it starts here and goes there. So everything is ordered, it becomes turbulent. Well, the flow is such that, well, pretty much the moon particles move like that, rather than, so instead of going forward, they go back and forth. So that's basically the idea. Hydrodynamic stability predicts transition between the laminar flow, which is fibrous flow, to something which might be less order. Initially, this flows of waters, but it is much more complicated. It's not straightforward. It's not unidirectional. Okay, this flow, the original flow might be unidirectional, so fluid flows in one direction. Is the correct unit. After bifurcation, it might start making this one, making vortices or something like that. Waves. We'll see that in our example, that we'll see waves. So that will show you the picture of the waves in like a square unit.
I understand why you can get we are actually telling up the visit to be here. I think that this one forces an extra. What with the fancy the external forces also. Like in many cases we skip the external forces. Like whenever we're studying the inertial sequence, only we're taking the inertial force and the other stress force. So we're just keeping the gravitational force. What will happen here if we skip this thing? What else in the last term? Whenever you adjust the SDX and some fraud number kind of thing. So that term actually you did index equal to PT and minus that term.
Is that how it
means if I skip that down, then will be different from this solution.
So for non-trivial solution to exist, just mathematical space, you need either non-trivial boundary conditions or you need to have force vectors. If
you don't have any sort of driving the system. So the system is lazy, it will not move. You will get trivial solution, so nothing will happen. So it will be frozen like blob. So it's,
So here the inertia term is balancing the pressure in this case.
you're talking about pressure. So if pressure is there is external force. Pressure is external. So if there is pressure, then you have external force. If there is no pressure, then there is no driving force, and it won't be much flow.
Okay.
Right? So it's simple as that. But if the fluid is viscid, so there is no resistance. And if there is pressure, like it will push the fluid and there is no resistance, so the fluid will start to accelerate. And so that's what will happen. So therefore, the question is, well, if it starts accelerating, nothing stops it from accelerating. What's it? And it still gets backed up, right? So that this does not happen from a point of view of conservation of energy. Motion cannot be infinitely fast because that means it will have infinite kinetic energy. Where does it come from? Right? So there is no such a thing. So therefore, very quickly we will realize that the assumption that fluid is invisible cannot stand. Physical it cannot hold. You can look at what happens away from, in some regions, away from the fluids, but fluids are always there, and the word viscosity is going to be always there. So like it or not like it, we don't like it because it makes equations more complicated. High viscosity is that. So no matter how you try, how hard you try, it is there. Well, unless you consider super fluid fluid at minus whatever, so it's almost zero, epsilon zero. So in that case, there are different things. So quantum effects are there. So these equations are not that good. So a little bit not good. Okay. But in real fluids, friction is supposed to be here. So viscosity is there. So to blow, just see we can ask it.
Start. And I just think
To go.
it's really okay.
This.
It cannot.
What's that? What's that? So
What it said with.
got it.
So then one of those things that is due for like 3 carry. Most things, but not of shit to me. From I think that is anything that goes that.
So maybe I have to pick up.
And so I didn't make as much. I thought was a mistake. Yeah.
You've done
Post in court. Yeah, that's it.
the what kind of
It is a dog of this. I'm kind of pretty cotton. Yes, that is 14 months and start time.